Alright, let's look at question number 20. We have been asked to state whether each of the following statements is true or false. Statement A. All even numbers are divisible by 2. Yes, they are. What are even numbers? Even numbers are the numbers which are divisible by 2. So definitely all even numbers are divisible by 2. That's true. Question B. Statement B. All odd numbers are divisible by 3. Is that correct? Just think of an odd number. Let's think of 9. Is 9 divisible by 3? Yes, 9 is divisible by 3. But what about, think of another odd number. Think of 11. Is 11 divisible by 3? No, 11 is not divisible by 3. So what does that mean? Can we say all odd numbers are divisible by 3? No. What are examples? 11 is an odd number, but it is not divisible by 3. 13 is an odd number, and it is not divisible by 3. So the statement here is false or wrong. Question C. Statement C. If the digital root of a number is 7, then that number is certainly divisible by 7. Alright, think of a number which has, or think of a number whose digital root is 7. One of the easiest numbers would be 25. What's 25's digital root? 2 plus 5 is 7. But is 25 divisible by 7? Does 25 come in the 7 times table? What's a 7 times table? 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28. So does 25 come in the 7 times table? No, it doesn't, which means 25 is not divisible by 7. 25's digital root is 7, but just because the digital root is 7, it won't become divisible by 7. So what's the statement here? They have said, if the digital root of a number is 7, then that number is certainly divisible by 7. It's a false statement. It is wrong. Statement D. If a number is divisible by both 2 and 3, then that number is certainly divisible by 6. Alright, think of a number which is divisible by both 2 and 3. Think of a number which is divisible by both 2 and 3. Let's say 12. Is 12 divisible by 6? Yes, it is. Alright, let's think of another example. Think of a number that is divisible by both 2 and 3. In the 3 times table, after 12 comes 15. But 15 is not divisible by 2. We've got to think of numbers which are divisible by both 2 and 3. How about 18? 18 is an even number, so it is divisible by 2. And 18 appears in 3 times table too. So 18 is a number which is divisible by both 2 and 3. The question is 18 divisible by 6? Yes, it is. So which means If a number is divisible by both 2 and 3, it is certainly divisible by 6 too. So the answer for this statement D is a true statement. It's true. Put a T. Let's look at statement E now. We have been told if a number is divisible by both 2 and 4, then that number is certainly divisible by 8. Alright, think of a number which is divisible by both 2 and 4. How about 16? 16 is divisible by both 2 and 4. And is 16 divisible by 8? Yes, it is. Alright, let's think of another number which is divisible by both 2 and 4. How about 20? 20 is divisible by both 2 and 4. But is 20 divisible by 8? Does 20 come in the 8 times table? No, it doesn't. So what does that mean? Just because a number is divisible by both 2 and 4, it doesn't become divisible by 8 too. Like just because a number is divisible by both 2 and 4, it doesn't automatically become a number divisible by 8. So the statement E is, if a number is divisible by both 2 and 4, then that number is certainly divisible by 8. It's a wrong statement. Just think of a number like 20. Or just think of a number like 28. Those are numbers divisible by both 2 and 4, but they aren't divisible by 8. So the statement E is incorrect. It's false. It's F.